If you could travel back to the very first moment of everything, you wouldn't see a bang, no flash, no fire, no explosion tearing through empty space, because there was no space yet. There was nothing for an explosion to happen in. Stay with me for a second. I know that sounds impossible. We grew up calling it the Big Bang. We imagined fireworks, a giant blast, something violent and loud. But that's not what happened. And honestly, what actually happened is stranger and somehow more beautiful than anything Hollywood ever gave us. If you were somehow floating there at the beginning of time itself, watching, your eyes wouldn't even work yet. Light didn't exist, not because it was dark. Darkness needs space, too. There was simply no yet. So what would you actually see if you could watch the birth of everything? Let's go there together. Okay, so let's slow down. Let's actually try to picture this. Not with the movie version in your head, but with what physics tells us really happened. Imagine trying to describe a place with no before. Not a place that was empty. Not a place that was dark. A place, if you can even call it that, where the concept of a place didn't exist yet. No up, no down, no distance, no time ticking forward. You can't stand outside it and watch, because there was no outside. There was no stage for the event to happen on. The stage itself hadn't been built. That's the part that breaks most people's brains the first time they really sit with it. We're used to thinking of the universe as something that appeared inside space, like a firework going off in a night sky. But space itself didn't exist before this moment. Time didn't exist before this moment. There was no 1 second earlier. There was no earlier at all. So if you were somehow there, not as a body, because bodies need atoms, and atoms didn't exist yet either, but if you were just awareness, floating at the edge of everything, what would happen first? Not light. Light comes later. Much later, actually. What happens first is expansion. Impossibly small, impossibly fast. In a fraction of a second, a number so small it doesn't even feel real when you write it out. Everything that would ever become anything was compressed into a space smaller than an atom. And then it stretched, not exploded outward like debris flying from a blast. Stretched. The way a photograph stretches when you keep zooming in and dragging the edges apart. Space itself grew. Scientists call this inflation, and it's almost impossible to imagine the scale of it. In that first blink, the universe expanded faster than the speed of light. Not by breaking the rules, because in this case, space itself was doing the moving, not anything traveling through space. The universe wasn't rushing away from a center. It was becoming bigger everywhere, all at once, like the surface of a balloon inflating, except there's no balloon. And there's no outside of it either. If you were watching, there'd be nothing to see. Because seeing requires light. And light, actual light, photons free to travel, wouldn't exist for a long time still. What you'd be present for if you were somehow just there is heat. Unimaginable heat. Energy so dense and so violent that the four forces we know today, gravity, electromagnetism, the strong and weak nuclear forces, were fused into one. One force, one rule, one kind of existence, before everything split apart into the physics we live inside now. And here's the part that gets me every time I think about it. Everything that would ever become a star, a planet, a mountain, an ocean, your own hands right now holding your phone. All of it was in there. Compressed, waiting. Not created yet, but present. Like a story that's already been written, just not yet read. You weren't watching an explosion happen to the universe. You were watching the universe learn what it was going to be, and it hadn't even figured out light yet. Here's something strange. For the first fraction of a second, the universe was too hot to have any shape at all. Not shape like a form, shape like rules. The laws of physics as we know them hadn't separated out yet. It's like watching a single note of music before it splits into a whole song. One sound, holding everything inside it, not yet decided. Then, Almost as quickly as it began, things started to cool. And cooling is when the story actually starts to make sense to us. Picture it like this. You know how steam turns to water and water turns to ice as things get colder? Each stage looks and behaves completely differently, even though it's the same substance the whole way through. That's roughly what happened to the universe, except instead of water changing states, it was the fundamental forces of nature themselves settling into place. Gravity broke off first, going its own way. Then the strong nuclear force. Then a little later, electromagnetism and the weak force split apart too. 4 different forces, born from one. And still, there was no light to see any of this by. What existed instead was a sea of pure energy, so dense that particles and their opposites, matter and antimatter, were constantly being born and instantly destroying each other. Imagine a room where every person that walks in immediately runs into their exact opposite and both vanish. That was the universe for a while. Creation and annihilation happening trillions of times over in less time than it takes you to blink. But something odd happened in that chaos. For every billion pairs of matter and antimatter that canceled each other out, one extra particle of matter survived. Just one. Nobody fully knows why. It's one of the real, unsolved mysteries in physics. Why there was slightly more stuff than anti-stuff. But that tiny imbalance is the only reason any of this exists. The only reason you exist. You are, in a very real sense, leftover material. The remainder of a subtraction problem the universe almost solved perfectly. Except it didn't. And thank whatever you want to thank for that. Because if it had solved it perfectly, there would be nothing here at all. No stars, no Earth, no you, listening to this right now. As the universe kept expanding and cooling, something else began. Protons and neutrons started finding each other. Not randomly bumping around forever, but actually binding, forming the first simple nuclei, hydrogen, helium, the lightest elements, the ones that would one day become the raw material for stars. Still no light, though. This is the part people find hardest to accept, even after all this. After the forces had split apart, after matter had won its narrow victory over antimatter, after the first atomic nuclei had formed, the universe was still a fog. A dense, hot, glowing fog of charged particles, so thick that light couldn't travel through it at all. Photons existed technically, but they couldn't go anywhere. They'd move a tiny distance and immediately smash into an electron, get absorbed, get released, smash into another one, trapped, like trying to see through a wall of frosted glass that goes on forever in every direction. So if you were there, watching, this is what you'd witness. Not darkness exactly, not light exactly, something in between. A universe that was glowing but blind to itself, radiant but unable to let that radiance travel anywhere. It had everything it needed to eventually make light visible. It just hadn't cooled down enough to let it loose yet. There's something almost human about that, if you let yourself sit with it for a second. Some things need time before they can be seen clearly, even by the universe itself. For nearly 380,000 years, this is how things stayed. A hot, glowing fog, trapping its own light inside itself. 380,000 years is a strange number to say out loud because it sounds enormous, and it is. And yet it's nothing compared to what came after. It's the universe's childhood. Slow, formless, waiting. But eventually, the fog began to thin. As space kept stretching, the temperature kept dropping, and something finally shifted. The charged particles, those electrons that had been zipping around freely, colliding with every photon that tried to move, started slowing down enough to actually bond with the protons around them. They paired up. They became neutral atoms, mostly hydrogen, and the moment that happened, something remarkable occurred. Light was set free. For the first time, photons could travel, not a few inches before smashing into something, but forever. Straight lines, uninterrupted, moving outward in every direction, finally able to go somewhere. Scientists call this moment recombination, which is such a clinical, boring name for something this enormous. I like to think of it differently. I think of it as the moment the universe opened its eyes for the first time. Not metaphorically, literally. This is the first light that ever existed in a form that could travel freely through space. This is the first thing that could, in theory, be seen. And here's what's almost unbearable to think about. If you slow down enough to really feel it, that light is still out there. Right now. Traveling. We call it the cosmic microwave background. And it's not some abstract concept sitting in a physics textbook. It's real, measurable radiation that's been drifting through the universe for over 13 billion years, stretched out now into microwaves instead of visible light, but still carrying the fingerprint of that first moment. If you've ever seen static on an old television, some tiny fraction of that static, a genuine, physical fraction, was ancient light from the birth of everything, hitting the antenna. You've technically witnessed the afterglow of creation and never even known it. But even after light was set free, it still wasn't the kind of seeing we imagine. There were no eyes yet, obviously. No stars either, not yet. If you were floating there, watching, you wouldn't see a bright, brilliant flash bursting outward. You'd see something closer to a dim, uniform, reddish glow, filling every direction equally, slowly cooling as space stretched it further and further into invisibility. Not fireworks, not a bang. Something quieter. Something closer to a sunset that never fully ends, fading everywhere at once. And then, for a long time after that, nothing. Darkness. Real darkness this time. The first true darkness the universe had ever known, because now the light had scattered so far apart that most of space was simply empty and dim, and there was nothing yet to make its own light. No stars, no galaxies, just faint clouds of hydrogen and helium drifting through the dark, pulled ever so slightly by gravity, waiting for something to happen to them. Scientists actually call this era the Cosmic Dark Ages. I've always found that phrase strangely moving. Even the universe had a period where it existed but hadn't become anything yet, where the ingredients were all there but nothing had ignited, where it was simply waiting, quietly, in the dark, for hundreds of millions of years. If you'd been able to watch it, this part might have felt like the loneliest part of the whole story. Everything that would ever become something, stars, galaxies, you, was already out there, scattered, unlit, unformed. But it wasn't nothing. It was potential, sitting in the dark, patiently, for longer than we can really comprehend. And potential, given enough time and enough gravity, doesn't stay quiet forever. Gravity is patient. That's something I think about a lot. It doesn't rush. It doesn't announce itself. It just pulls. Quietly, constantly, for as long as it takes. And in that dark, empty stretch of the early universe, gravity was doing the only thing it knows how to do, pulling the slightly denser patches of hydrogen and helium a little closer together. Bit by bit, atom by atom. For hundreds of millions of years, in near total silence, gravity was building something out of almost nothing. If you were watching this part, you still wouldn't see much. Faint clouds, slowly thickening in some places, thinning in others. No drama, no sudden burst. Just the slow math of physics, doing what it always does. Patience compounding into consequence. But somewhere in that darkness, a threshold got crossed. A cloud of hydrogen, pulled together by gravity for long enough, finally became dense enough, and hot enough, at its very center for something new to happen. Hydrogen atoms, crushed together under their own weight, began to fuse. And fusion, when it starts, doesn't stay quiet. The first star ignited. I want you to actually sit with that for a second, because it's easy to say those three words fast and miss what they mean. For the first time since the birth of the universe, there was a source of light that made its own light. Not leftover glow from creation, fading into microwaves. Not the dim afterimage of recombination. An actual, burning, self-sustaining source of brightness, switching on in the middle of all that darkness. If you'd been floating there, watching, this is the moment that might have actually looked like something. A single point of light appearing out of nothing in the middle of an ocean of black. And then, not long after, in cosmic terms, another one and another, clumps of gas collapsing here and there, each one crossing that same threshold, each one lighting up on its own. Not all at once, not a single flash. More like watching a city at dusk, one window at a time as people quietly get home and switch on their lights until slowly an entire skyline is glowing. These first stars were nothing like our sun. They were monstrous, some of them hundreds of times more massive, burning so hot and so fast that they lived short, violent lives, measured in mere millions of years instead of billions. And when stars that large run out of fuel, they don't fade quietly. They collapse in on themselves and then explode outward in supernovae, so powerful they can, for a brief moment, outshine entire galaxies. And this is where the story turns into something personal, even though it sounds like it's just about physics. Because inside those first stars, and in the explosive deaths that followed, something was being built that hadn't existed before. Heavier elements, carbon, oxygen, iron, calcium. The stuff atoms need to become more than just hydrogen and helium drifting in the dark. The stuff, eventually, that would become bone. And blood. And the calcium in your teeth. And the iron in your blood. And the oxygen you just breathed in without thinking about it. You are not separate from this story. You're not watching it from a distance, safe on the sidelines of some ancient event that has nothing to do with you. Every heavy element in your body was forged inside a star that lived and burned and eventually died, so that something like you could exist billions of years later. Those first points of light in the darkness, they weren't just illuminating the universe, they were building you, piece by piece, element by element. Before there was ever an earth to stand on, before there was ever a sky to look up at, the raw material of you was already being cooked inside the hearts of dying stars. Once the first stars started dying, something changed in the darkness. Not just light now, but structure. Because when a massive star explodes, it doesn't just scatter new elements into space randomly. It sends out shock waves. Waves that ripple through nearby clouds of gas, compressing them, disturbing them, nudging them toward collapsing in on themselves too. One star's death becomes the trigger for the next generation's birth. It's almost impossible not to notice the pattern here. This isn't a straight line of creation. It's a cycle. Something ending so that something else can begin. Stars started clustering. Gravity, still patient, still pulling, began gathering not just individual stars, but entire groups of them, along with vast, invisible amounts of dark matter that we still don't fully understand, even now. These clusters grew. They pulled in more gas, more dust, more stars being born within them. And slowly, over hundreds of millions of years, they took shape into something we'd actually recognize if we looked up and saw it. Galaxies. If you were watching from far enough away, which, remember, is exactly what looking through a telescope actually does, because light takes time to travel, so looking far away is looking back in time. You'd start to see these vast, spinning collections of stars taking form. Some would be small and irregular, chaotic clumps of light. Others would begin to organize into the elegant spirals we know today, with long arms of stars curling outward from a dense, bright center like a whirlpool caught mid-motion. Our own galaxy, the Milky Way, was one of these. It didn't spring into existence fully formed. It grew the same slow, patient way. Smaller structures colliding and merging with each other over billions of years, gravity stitching fragments together into something whole. In fact, it's still doing this. Right now, the Milky Way is slowly consuming smaller neighboring galaxies as we speak, so gradually that we'd never notice in a single human lifetime or 100 lifetimes. But it's happening. This story never actually stopped. We just don't live long enough to watch it unfold in real time. And somewhere inside one of these galactic arms, one unremarkable spot in one ordinary spiral galaxy among hundreds of billions of stars, a cloud of gas and dust enriched with all those heavier elements forged by earlier generations of dying stars began to collapse in on itself. Gravity again. Patient, unglamorous gravity, doing what it always does. Most of that material collapsed into the center and ignited. Our sun, but not all of it. A thin disk of leftover material spun around the newborn star, and within that disk, smaller clumps began to stick together. Dust to pebbles, pebbles to rocks, rocks to boulders, boulders over millions of years to planets. One of those planets, the third one out from that particular star, not too close, not too far, sitting in that narrow, fragile band of distance where water can exist as a liquid and instead of freezing solid or boiling away, was Earth. It's strange to say it plainly like that, but it's true. If you rewind everything all the way back, past your own life, past every generation of your family, past humanity, past every living thing that ever crawled or swam or breathed, you eventually arrive here, at a cloud of dust gathering itself together in the aftermath of stars that lived and died so that this exact moment could happen. You didn't just come from stardust as some poetic phrase. You came from an actual physical chain of events. One star's death making room for another star's birth, again and again, until finally, one small rocky planet formed in exactly the right place, at exactly the right distance to eventually hold you. Nothing about this had to happen, and yet, somehow, watching from wherever we're watching from now, it did. So here's where we are. A universe born from something smaller than an atom. Light that took 380,000 years just to be set free. Stars that lived and died so violently, so completely, that their remains became the very atoms sitting in your body right now, as you listen to this. And if you've made it this far with me, through the fog, through the dark ages, through the birth of the first stars and the slow, patient stitching together of galaxies, I just want to say something real for a second. This channel exists because of people like you. People who are still curious about where they actually came from, who don't just want the short version, who are willing to sit in the dark parts of the story because they know something beautiful is waiting on the other side of it. If that's you and you're not subscribed yet, I'd genuinely love to have you stick around. We do this every week. Take something huge and impossible sounding and try to make it feel personal, because it is. And I'm curious about something. If you had actually been there, floating in that darkness, watching the first star ignite, what do you think you would have felt? Not what you'd think. Scientifically, what you'd feel. Tell me in the comments. I read every single one, and honestly, some of the most interesting parts of making this channel come from what you all bring to these conversations. Okay, back to it. Because we're not done yet. There's one more piece of this story, and it might be the strangest part of all. Everything I just described, the stars, the galaxies, the slow formation of Earth, happened over the course of roughly 9 billion years. 9 billion years passed before our solar system even existed. Let that sink in for a second. The universe was already more than 2/3 of its current age before the raw material for you even finished forming. And once Earth did form, it was nothing like the blue, living planet we know now. It was a molten, hostile ball of rock, constantly being struck by debris left over from the solar system's formation. One of those impacts most scientists believe was so massive, a collision with a planet-sized object, that it knocked a chunk of Earth loose entirely. That chunk didn't fly away. It settled into orbit. It became the moon. So even the sky above you, the quiet presence you probably don't think about most nights, was born out of violence. A collision so catastrophic it should have ended everything, and instead, it gave us the very thing that stabilizes our planet's tilt, that creates our tides, that made a stable enough environment for life to eventually take hold. Violence, becoming stability, destruction, becoming the exact condition needed for life. This pattern keeps repeating, doesn't it? Nothing in this story happened gently, and yet, somehow, gentleness, life, Ocean's You, is what it was all quietly building toward the entire time. So, if you actually could have watched it, the whole thing, from the very beginning, here's what you'd know now that you didn't know at the start. You wouldn't have seen a bang. You would have seen nothing for a long time. Then heat, with no light to carry it anywhere. Then a fog that trapped its own glow inside itself for 380,000 years. Patient in a way that doesn't feel like it should be possible for something without a mind. Then light, finally set free, fading into a dim, uniform glow that's still out there right now, drifting past you as you listen to this. Then darkness again, real darkness, the loneliest stretch of the whole story. And then, out of that darkness, one point of light. And another. Windows switching on across a skyline nobody had built yet. Stars living hard, dying young, scattering the exact ingredients that would one day become bone and blood and breath. Galaxies stitching themselves together out of wreckage. A star of our own igniting in an unremarkable arm of an ordinary galaxy. A small, rocky planet forming in exactly the narrow band of space where water could stay liquid. A collision violent enough to tear a piece of that planet loose. And somehow, that violence is the reason the sky above you has a moon in it tonight. None of it happened gently. And all of it happened so that something gentle could eventually exist. You. Here's the part I keep coming back to every time I sit with this story. You weren't watching this from somewhere outside of it the whole time I've been talking. You're not separate from any of it. The calcium in your teeth, the iron carried in your blood right now, the oxygen you just breathed in without noticing like you always do. All of it was written into existence long before there was an earth to stand on, or a sky to look up at, or anyone around to wonder where they came from. You didn't come from nowhere. You came from everywhere. From the whole story. If this stayed with you at all, even a little, do me a favor and share it with 5 people. Not because I'm asking you to boost a video, because some things are actually worth passing on. The way this story got passed on to you, through 13 billion years of stars living and dying so it eventually could. And before you go, I'd really love to know. What's something you've always wondered about but never actually looked into? The kind of question you've carried around for years without an answer. Leave it in the comments, honestly. I read them, and who knows, it might be exactly what we dig into next. Until then,